Hi everyone, I am Sohom Ghosh and I shall be presenting our paper Data-Driven Content Creation using Statistical and Natural Language Processing Techniques for a Financial Domain. It has been co-authored by Ankush Chopra, Pratik Nagwanshi and me. This work has been done at Fidelity Investments, one of the top fintech firms. Let me start with a brief overview of the paper. Investors interact with Fidelity either using low touch channels like search and virtual agents or high touch channels like chat or calls. The low touch channels have lesser operating costs compared to the high touch ones. Our aim is to save time and a cost by transferring users from using high touch channels to low touch channels. We have designed a solution for this problem, which consists of two parts. The first part relates to topic detection and clustering. The second part relates to converting user search queries to questions. This enhances the process of manually creating relevant contents. Our dataset consists of 1 year worth of customer interactions through various channels like search, live chat, and calls. The time period we considered is from June 2020 to May 2021. The data distribution is presented over here. Let me now explain the pre-processing steps. For calls, we consider only inbound calls. Customer service representatives, commonly referred to as reps, write summaries of a conversation after a calls. We refer to them as rep notes. So transcripts of inbound calls having less than equals to 6 words in rep notes have been used. System messages and personal information of customers has been removed. For search queries, we considered only those which had been searched at least 5 times. It covered 97% of the entire search volume, and by doing this, we could effectively remove the long tail. We also remove search queries with stocks or mutual fund tickers. Now, I shall discuss the methodology we followed. It consists of two parts. Firstly, combining search queries, which are generally short in length, with calls and live chat interactions, which tend to be longer. In order to do so, we extracted intents from calls and chats using a stacked bidirectional LSTM model. We then cluster these by using agglomerative hierarchical clustering. In the second part, we match the search queries with questions from our predefined question bank and return relevant queries. This process involves question detection, question aggregation, embedding creation using a TF-IDF, and sentence BERT. The embedding has been created using both TF-IDF and a sentence BERT. Then we map the search queries to relevant questions. The theme extraction model mentioned in the previous slide takes transcripts and rep notes as inputs. It has an encoder part and a decoder part. Its task is to extract rep notes like themes from call transcripts. Let's understand the whole process by means of this flowchart. For the first part, we take search queries and pre-process them by removing the ones which have mutual fund or stock tickers. We then expand the acronyms. After that, we create a combined list of clean search queries with intents from chats and calls. We use a custom entity tagger which has been built uh, in-house to detect entities from these. Finally, we hierarchically cluster them after creating their embeddings using Robota. We store the embeddings of the centroids to assign clusters for the new interactions which we get from time to time. In the second part, we expand the acronyms present in search queries and extract their embeddings using sentence word. We also extract their TF-IDF values. We do the same for the question bank we have. Finally, we match these two based on cosine similarities. We kept the similarity threshold to 0.89 for TF-IDF and 0.86 for sentence BERT. We used both these scores to ensure that TF-IDF is taking care of the syntactic matching aspect and sentence BERT is taking care of the semantic matching aspect. So here are the results. On the left hand side, we present the output for the first part of our work. It is a dashboard consisting of organically created clusters from interactions investors had with Fidelity. This helps content creators decide on what they want to prioritize. The right hand side of this slide consists of precision of TF-IDF model and a sentence BERT model which we use for creating embeddings at different thresholds. You can also see the questions we have extracted from the search queries. For search queries like tax form and direct deposits. So in this paper, we presented a solution to extract insights from interaction data by clustering them hierarchically. It also helps in creating of intent hierarchy which business needs. Moreover, the output helps content creators to prioritize their work. In future, we would like to incorporate market events uh, and we would also like to remove the questions for which the content already exists. We also want to evaluate our system using external parameters like reduction in call volume. So these are the list of papers we referred to. Thank you all for listening. Any questions?
Okay, that seemed to work okay. Hope everybody could see that and hear that. Thanks very much, Sohom and Pratik. So you're there live to answer questions. If anybody has any questions, please just unmute and ask a question or post it in the chat. But while people are thinking of some questions, I'll start off if that's okay. So I'm assuming everything in your corpus data is English, is that right?
Yeah, you're right.
Okay. And it's all from American English, British English, or international varieties, or is there any kind of code switching or other things that you have to filter out or anything?
No, we didn't have to do any code switching because our customers, the investors, they're based out of US. So we are mainly operating the US region, so we don't have to do any code switching for that.
Right, right. And in terms of the quality of the transcription, it sounded like it was automatic transcription, was
Yeah,
it? How good is that?
so that transcription wasn't very good. There were some issues with the transcription engine, but the rep notes were the manually written rep notes. The notes which the customer service representative have written, they were of better quality. Although they use their different lingos, they are very different from what we have in general English. I mean, some short forms and all, but they were quite well structured. But the transcription engine, there were certain things which were getting masked and certain things which were not getting transcribed.
Right, right. Okay. Thanks. So there's a question popped up from John, which I'll read. Thank you for the presentation. Could you elaborate more about how the acronym expansion is performed? Is there a dictionary you're relying on?
Yeah, so for the time being, we have a inbuilt dictionary. We use that. Apart from that, a few months ago, we all also crawled several acronyms and their full forms
from the internet. So that also you use while expanding the acronyms.
Yeah, can you use anything like Wikipedia or something to kind of constantly update that? Is that an option for you?
Yeah, this was for a different project, not for specifically for this project. What we did is we crawled some of the company reports which was available. From there, we extracted the acronyms, and we have a list of acronyms which we use for expanding.
Right. Okay. Yeah. So presumably the company would expand the acronyms themselves on their first use. You would hope,
Yeah,
or have
exactly.
some kind of glossary. Yeah.
Yeah.
Okay. So just coming back to my previous question about the transcription quality, does that have knock-on effects on the other parts of your system? If the quality drops, do you just kind of say, if it's below a certain threshold, you'll throw that piece of text
Yeah.
away?
So the transcription engine is something which we don't control. We can't do anything about it. What we have in control is whether to show up the summary, whether to use that particular theme or the summary which has been extracted or not. So whenever we find that the probability with which the summary is getting extracted that is very low, then we don't show it explicitly.
Right.
Even for the clustering piece, whenever we find that the cosine similarity is low, we don't assign clusters uh, to the calls transcripts and all. We just say that we are not confident, so we won't be clustering these things.
Yeah. Okay. Seems sensible. Okay. Let me just check for any further questions. I can't see any popping up, so I think we can probably stop there unless there's any coming in at the last minute. So thank you very much again.
Thank you. Thanks for having us here. Thank you.